Okay guys, so in the first video what we did was we were going through all the steps to derive the binomial expansion formula. So we looked at Pascal's triangle. If you remember, this was a plus b to the 0 is 1, a plus b to the 1 is 1a plus 1b, a plus b squared, 1a squared plus 2ab plus 1b squared, etc. Okay? And what we noticed that every time these powers, so remember this is a squared times b to the 0, these powers always added up to this power here. See, this is a to the 1, b to the 1, so the powers added up equals this, and b squared equals this, doesn't it? Okay? So what we noticed was that each time this power started with the n, and b started with 0, and then this a reduced by 1 every time until finally it went to 0, whilst this b, the power, increased by 1 all the time going up to the final n. That was the pattern we noticed from Pascal's triangle. We then used the theory of combinations, this whole n choose r, in order to show the coefficients of say anything that we wanted. So if some smart ass came up to you and said, look at this expansion, what's the coefficient of x to the 19? You would use your theory of combinations. So you would say, right, so n is 20, choose, and our r is this 19 here, isn't it? So n choose 19. And you would whack that in the calculator and you would get 20x to the 19, wouldn't you? But remember, we have this 1 here, so this would be 20x to the 19 times 1 to the power of 1, so 20x to the 19, yeah? Okay, so we figured all that out, but what we need to do is we need to put it in a general form, and this is the binomial expansion formula. So this is what I'm going to give you now. I'm going to give you the actual binomial formula, but then I want to go one step further and give you one which is far more useful and easy to remember and far more robust. Okay, so the actual binomial formula is a plus b to the power of n equals n choose 0. Remember, this is in column matrix form, okay, which is the same as n choose r. N choose 0, a to the power of n, b to the power of 0, plus n1, a to the power of n minus 1, b to the power of 1, plus n2, a to the power of n minus 2, b squared, plus dot dot dot, plus n, whatever r we're looking for, a n minus r, b to the r, plus dot dot dot, plus, and then finally n choose n, a n minus n, which of course is 0, b to the power of n. Okay? So we know all this. We knew all of this, really, but we just didn't put it together formally. So this is the formal binomial expansion formula. But the one I want us to know goes one step further and makes it so much easier, because this looks rather complicated, I think. But if we say let a equal 1 and let b equal x, we get 1 plus x to the power of n. And this, if you did all the theory of combinations and all that kind of stuff, will end up with this lovely formula here. So over 2 factorial times x squared plus n, you'll notice a pattern, n minus 1, n minus 2, 3 factorial x cubed plus dot 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 goes all the way to the end, okay? Now the reason why I'm not writing an ending here is because, remember, this is C2 and C4 combined, so in C4 you're not going to have an ending. So we're going to talk about that afterwards. Maybe we'll have to talk about it in the next video. We'll see how this goes. So this is our formula now to use. So every time we get an expansion, we need to get it in this form here. What's the most important number here is this 1. So this always has to be 1. This x can be anything. It can be half x, it can be a quarter x squared, it can be anything. And you'll see what I'm talking about on the next slide when we go through some examples. Okay, so here's an example, an easy example to start with. The question is saying expand 1 plus x all to the power of 5 using the binomial formula. So, we can do this. This is easy. We could use Pascal's triangle if we wanted to, letting a be 1 and b be x. But let's use this binomial expansion formula. Because remember, normally questions will ask you, say, expand, for example, 3 plus x over 2 to the power of 20, okay? But they would always say up to, say, the x to the power of 4th term, okay? Or they would ask you, what's the coefficient of x over 2 to the power of 18? Or something like that, okay? So, that's what we'd lead up to, and in C4, sorry, you'll be looking at infinite series where they converge, okay? But we'll talk about that in a bit. Let's concentrate on this example for now. So here in this example, n must be 5, mustn't it? So, using my expansion formula, 1 plus x all to the power of 5 equals 1 plus n is 5, and then whatever here is, it's x, isn't it? Plus 5, and then n minus 1, so 4 over 2 factorial, this whole thing squared, plus 5, 4, 3 over 3 factorial, this whole thing cubed this time, plus 5, 4, 3, 2 over 4 factorial, x to the power of 4, plus 5, 4, 3, 2, 1, 5 factorial, which of course straight away you should notice, oh, 5 factorial is this thing here, so that's going to cancel down to 1, isn't it? X to the power of 5. So let's simplify this up then. Oops. Let's simplify this finally, and we get 1 plus x to the power of 5 equals 1 plus 5x plus the 2 factorial would cancel here to get 5 times 2 is 10, so that's 10x squared. And then you have 3 factorial divided by this, so this will be, so I don't have to use a calculator here, do I? 3 divided by 3 factorial is 3 times 2 times 1, x cubed, right? So 3 will cancel, this will cancel with a 2, so I would get 10. Well, I'll just simplify that finally in a minute. The last one down here, again, let's simplify that. 5 times 4 times 3 times 2, all divided by 4 factorial is 4 times 3 times 2 times 1. So the 4's will cancel, the 3 will cancel, the 2 will cancel, so I just get 5 divided by 1 times x to the 4. Plus, we already said here that this is 5 factorial divided by 5 factorial, so that's just 1 x to the 5. So to simplify, 1 plus x to the 5 equals 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the 4 plus x to the 5. Done. That's the first example done. You notice, well, straight away I'm pretty confident this is correct because it's symmetrical. 10 and 10, 5 and 5, 1 and 1 is the coefficients, yeah? They're all in ascending powers of x, so this is good. Okay, so this example now is looking like a typical exam question, okay? So we've got it. We've got 2 minus x all to the power of 10, so it's massive, isn't it? We're not going to expand all that. But the question says up to the term x cubed, okay? So we're going to go up to the term x cubed. This, though, is not in the form we need it. Remember, it needs to be, this number has to be 1. So to get this, firstly, in the form we need to take this 2 out of everything. So we're dividing everything by 2, taking a factor out of 2. But it's not just 2, because it's to the 2 to the power of 10, remember. So 2 minus x to the 10 actually equals 2 to the 10, and then everything inside here divided by 2. So 1 minus a half x to the power of 10. Such a crucial step. You must do this step, okay? It's really, really important. So now we can expand as normal. So it's 2 to the 10. We're going to leave that outside, okay? Now we do it as normal. So we always start with 1 because we've got our 1 there, yeah? Plus nx, so n is 10 and x is minus a half x, okay? Really important you put the whole thing in brackets. Plus n is 10, n minus 1 is 9, all divided by 2 factorial. Whatever is in there is our x squared. Remember, we're only going up to the third term, so I have 10, 9, 8 over 3 factorial minus a half x all cubed plus ... Don't care about anymore because the question only asked up to x to the power of 10, x to the power of 3. So let's clear this up. So this is 2 to the power of 10 times 1 minus 10 times, the reason I say minus because 10 times minus a half is minus 5x, isn't it? Plus 10 divided by 2 factorial is 5, so 5 times 9 is 45, so I get 45, and then if I put minus a half squared, then if I put minus a half squared here in my calculator, I would get a quarter, so I get a quarter times x squared, yeah? And then minus again, because this is cubed, so this is going to give us a minus. 10 times 9 times 8, all over 3 factorial, let's do that in the calculator. Divided by 3 factorial is 120, so I get 120, and then minus a half, all cubed. As I say, this already gave us this minus sign, so this would be 1 over 8 x cubed, ... And then a final clear up then. So 2 to the power of 10, put that in my calculator, is 1024 minus, because remember I'm just timesing this by this, times this, or this, 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 and final clear up, yeah? So 1024 minus 5 times 1024 is minus 5120x plus 45 times a quarter times 2 to the power of 10 is 11520x squared, and finally minus 120 divided by 8 times 2 to the power of 10 is 15360x cubed plus ... And we're done. We've expanded it, haven't we? That would have taken you forever using Pascal's triangle, wouldn't it? Okay, that would have been really difficult. It would have taken you forever, but look how quickly we've done that. See you in the next video for much quicker examples, and especially for the C4 stuff, okay? So yeah, if you want the C4 stuff, you need to go to the actual binomial C4 specific video, okay? C2 stuff we're going to continue in this title, so it's going to be part 3, okay?